Let's see the next topic, file access methods. Okay, we need to access a file when a process is used that particular file. That means we need to read the contents of the file, with contents within the file when a file is used. Okay, because file stores the information in the secondary storage, the information brought from your secondary storage to primary storage. Okay, there are three ways the file can be accessed. First one, sequential access. Second one, direct or relative access. Third one, indexed access. Okay, so let's see sequential access. In the sequential access, the file information is processed in the order. That means it will be read one record after other record, one record after other record. That means the data will be accessed sequentially, one after other. That means if you read this particular block number 0, the next one you are reading is block number 1, 2, 3. Okay, so when it comes, that head movements will be very less when it comes to changing from one block to other block. Okay, so the best example for sequential access is your editors and compilers that usually access the files in sequential order. Okay, so read and writes make up a bulk of operations on a file. Read next operation reads the next portion of the file, automatically advances the pointer to the next location. Okay, so write next operation appends the file, appends to the end of the file. The data will be added at the end of the file. That means if there is some data that is stored, let's see, file access methods. So this is the contents that is currently written on f1.txt. Okay, so when you want to perform a write operation, the position will be pointing to this location. Okay, so from here onwards you need to write the other data, that is operating system and etc. This data will be added at the end of the system. When you perform a write operation, the write operation will be performed from file, so it will be starts from here. Okay, so the read next and write next will read the corresponding blocks of. In direct access method, we don't need to read the data sequential. Okay, so we can read the data any order, not in the sequential order. Okay, so what is a file? A file can be viewed as or treated as a numbered sequence of blocks, a numbered sequence of records. Okay, so because file is made up of fixed length records that allow the program to read and write with no particular order. Okay, we don't need to read the data in a sequential access. Okay, so the devices that support this particular direct access or relative access, we can call it as random access devices, because we can read any block of data. So that means we can read the block 7 first, followed by block 53, followed by block 98, followed by block 183. Okay, so we don't need to go 7 to 53 by reading 8, 9, 10, etc. Okay, so that means if you take write of 7, it will write the data onto the 7th block, or if you take read on 7, it will directly go to read 7th block, and then we can read the data 53, and then we can read the data 98. Okay, by writing the block number we can directly go to that particular file. Okay, that particular block. Okay, so we don't need to read the data in a sequential manner. And the best the databases are using direct access types, and we can use the airline reservation system as an example. Suppose that we need to have information regarding the flight number 750 or flight number 1000. They are stored in a particular block number, so we can directly go to, suppose that a flight number, let's say take Indian Airlines IA301. Okay, so this particular flight, and I assume that this is our ID, and this particular file is stored on the block number 750. Block number 750, we need to find an information regarding this particular file, whether how many passengers are already registered, that is booked the flight, and when the how many seats are left and how many seats are booked, all this information is present in this particular block number 750. So we don't need to go from 012, we can directly go and access the information of this particular 750 directly, either by, if some particular passenger has booked the ticket, we need to store the information onto that particular one. If anyone want, after booking that, if you want to access the access the information, that is status information, we need to store it on the file number 750 directly, that block number 750 directly. Okay, so there are two operations again, read operation and write operation. We need to specify on which block this particular read and write operations are performed. That is read 750 will take the particular from 750 block the data will be accessed, and write 750 we need to store the information on 750th block. Okay, so n is the relative block number, that is from the start how many blocks we need to move. Okay, right, and always the relative block number starts from. Next one is index access method. Okay, so this index access method is similar to your book index page. So at the last your book will have an index and corresponding page numbers. Okay, your book will have an index page and set of all topics names will be there. In that particular topic name, the opposite way you can find a page number. You can find the page number. If you go to that particular page number, you can get all the information regarding that particular topic. Okay, similarly in the system also we'll use the index access method. Okay, so in the index access method there will be an index, there will be an index. Okay, and there will be some logical record number, so this will be maintained in a file called index file. Okay, so we'll maintain a set of uh, pointers. Okay, and to that particular logical record. Okay, so when we want to find a because a file is a collection of records, a file is a collection of records, a file stores several records. To find a record in the file, to find a record in a file, we first search this particular index. The first column will be your index, and if we find this particular index, okay, we'll use a pointer to go to the logical record and to access this particular information. Okay, so the index file stores your index as well as a pointer. This particular pointer will take you to the original location where it was present, the where the data was present within the file, inside the file. Okay, so for search purpose, we use binary search. For search purpose, we use binary search. Binary search will take less time as compared to our linear search or sequential access. Okay, so to read a file or write a file, to read a file and write into the file, we use a binary search and we find the file and we locate the file. Through the pointer, we'll go to the actual location within the file where the record is present. Okay, so with large files the index file itself may become too large to kept in the main memory, because this particular index file should be kept in the main memory. So we can use, when it comes to large files, we need to create index to the index file, that is multi-level index files. Okay, so where the primary index files contains the pointer to secondary index files, and this particular secondary index files in turns point to the actual data records or data items in the file. Okay, so the IBM index sequential access ISAM uses a small master index that points to the disk blocks of a secondary index. Okay, the secondary index blocks points to the actual file contents within the file. Okay, so let's see next topic. Let's see the next topic, directory and directory structures. Okay, so files are stored on any random access devices that are either your magnetic disk, that will be your hard disk, or optical disk, SSDs, and CDs and DVDs. Okay, so these magnetic disk and solid state disk, these storage devices can be divided can be used for a file system. Okay, so these disks are again subdivided into partitions and volumes, etc. Okay, so We can divide the entire space of a disk into different quarters or quarters. Okay, so here let's see this particular thing. We have divided the entire magnetic disk into three parts, so it will have a name C, D, E. Okay, so each partition, so a file system can be treated as, can be created on each of this disk partition. That means we can install operating system on each of these partitions. So we can have three operating system. We can able to install three operating systems. Okay, any entity containing a file system is called a volume. Okay, the information regarding this particular volume is maintained in a table. Okay. So each volume can be taught as a virtual disk. Volumes stores multiple operating system. That means each volume can store one operating system. Okay, they can be run, and they can be, we can run one operating system on each partition. Okay, so each volume containing a file system maintains the information about the files in the system, and the information kept in the entries called device directory or volume table of contents. The device directory records the information such as name, location, size, and types of all files on the volume. Okay, so this division of an entire disk to partitions, the major advantage is this can allow to run multiple operating systems. Okay, so each volume we can install one particular operating system, and we can run more than one operating system on each partition, but we can run one operating system on each partition. Okay, and the directory structure. Okay, this directory structure keeps the information about all files that are stored on the secondary storage. This is a where this particular directory structure will be stored, which is stored on the secondary storage. Okay, this will be stored on the secondary storage, which will have all the information regarding the files. When a file is created, the file will be the file entry, there will be an entry created for that particular file in this particular directory structure. So to organize the files in the system, okay, there are several methods that we are used. Okay, so they are single level directory, two level directory, state structure directory, acyclic graph directories, and general graph directories. See, before going to this one, what are the operations that can be performed on a directory? So these are the operations that can be performed on a directory. First one, we can create a file, delete a file, list directory, rename a file, and traverse the file system in a directory. So if we create a file, a new file will be created, its entry will be added to directory. Whenever a new file will be added or created, okay, its entry must be added to your directory. So once you add, that means a new row will be created. In that particular row, it will be add all the information regarding the file, what is the file name, file identity, and location, and etc. Okay, so when a file is deleted, its entry is deleted from the directory. Okay, so if we want to list all the contents within a directory, okay, we need to use the list directory operation, and we can rename one file with other file name with other file, that is cscc.txt, we can convert it into csc.txt. Okay, so next, that we can traverse the file system, that is if you want to wish to access every file in the directory, and access every directory and every file within a directory structure. Okay, right, that is called traversing